The heavens are not silent, though their voice is woven in frequencies too slow for the human ear to ever catch. Across the cold dark beyond Neptune, beyond Pluto, and beyond even the Oort's speculative haze, something faint shimmered in the depths of 2024's night sky. A ghostly trail of light, so dim it nearly dissolved in the static of starlight, was registered by the vigilant gaze of Atlas, the asteroid terrestrial impact last alert system, a set of robotic eyes that sweep the heavens for wanderers of stone and ice. But this was no ordinary comet, no ordinary asteroid, no child of our sun's long family. Its orbit was not bound. Its velocity was not a local whisper. Its vector pointed from the deep between stars. It bore the cosmic passport of the interstellar. The designation came quickly. 3I Atlas, the third known interstellar interloper after the slivered enigma of 1I ʻOumuamua and the icy visitor 2I Borisov. Already the numbering whispered of its rarity. A species of celestial traveler so scarce that only 3 have ever brushed our solar system in the entirety of recorded astronomy. Each one, like a half-forgotten dream, tore holes in the fabric of certainty. And this one, Atlas, promised to be the most confounding yet. What gave it its voice was not the glow of its own making, but the sun's reflected off surfaces no one could yet picture, off textures unseen. Yet the faintness suggested strangeness, too dim for its apparent size, too irregular for ordinary comet dust, too steady in its flicker. Its trajectory spoke more loudly still, a path tilted steep against the ecliptic, threading a course that would bring it not just past Earth's orbit, not just grazing Jupiter's watchful domain, but astonishingly, near Mars itself, an encounter almost impossibly timed. It is here, in this improbability, that the cinematic unease grows. For Atlas was not merely another comet to chart, another frozen refugee from beyond. Its very movement seemed to breathe with a quiet defiance. The silence surrounding it would only deepen. Instruments went dark, telescopes blinked into emptiness, data streams broke like snapped threads, and in the corridors of officialdom silence. No statements, no confirmations, only unanswered questions. The stage was set, an interstellar visitor, a near-Mars passage, and a sudden shutting down of the instruments that watched it. A mystery not written in flame or collision, but in absence, in the hush between signals. The story of 3I Atlas would not be a tale of fiery spectacle, but of silence echoing across the vastness of space, daring humanity to wonder whether what passed before us was a natural stone or something altogether more profound. It began, as so many great astronomical stories do, in the quiet stillness of a late night at the summit of Mauna Loa, Hawaii. The Atlas Survey Telescope, designed for urgency rather than grandeur, spends each evening sweeping wide swaths of the sky for faint moving objects, its mandate to catch potential Earth impactors before they arrive unannounced. In March of 2024, one such sequence of exposures revealed something unusual. At first, the moving point of light was unremarkable, another distant speck drifting slowly against the fixed stars. Yet its motion, when measured carefully, told a different tale. The team of astronomers on duty compared the new discovery against catalogues of known comets and asteroids. Nothing matched. Orbit-fitting software began to run. Within hours, a realization spread through the watchful night. The eccentricity of this object's orbit was greater than one, not bound, not a citizen of the solar family. Instead, an outsider, an interstellar drifter, had once again wandered into human sight. Its first signature was faint, so faint it danced near the limit of detection. The object did not brighten dramatically, as icy comets often do when heated by the sunday. Instead, It maintained a stubbornly dim profile, as if resisting the warmth of our star. The spectral analysis, though crude at first, suggested a cold body with unexpected reflectivity, brighter than some asteroids, darker than others, almost paradoxically balanced. The Discovery team issued a circular through the Minor Planet Center. Almost instantly, telescopes across the world turned their lenses toward the coordinates. The excitement was palpable. In the wake of ʻOumuamua in 2017 and Borisov in 2019, astronomers had waited hungrily for the next interstellar guest. The first had astonished by its cigar-like shape and anomalous acceleration, the second by its more comet-like familiarity. Now came the third, an unknown that carried with it the promise of clarity or of new confusions. Who were the key players in this act of unveiling? It was not a lone genius peering through an eyepiece, as in centuries past, but rather a networked web of human effort. Atlas itself, the automated sentinel, passed its discovery to coordinators at the University of Hawaii's Institute for Astronomy. Teams at Pan-STARRS, Gemini Observatory, and smaller amateur outposts in Europe and Asia confirmed the strange orbit within days. The discovery belonged to all and to none, another shared artifact of humanity's skywatch. And yet, beyond the technical recognition of eccentricity, there was the quieter, more haunting recognition. Another messenger had entered our domain. Each such visitor arrives only once, never to return, a solitary ambassador from a distant stellar nursery or shattered world. They carry in their structure, their chemistry, their speed, the encoded history of a place we may never otherwise glimpse. This too was why astronomers dropped everything to track Atlas. The universe had delivered a gift, and it would not linger. What was the object doing, out there in the dark? Its light curve showed subtle variations, flickers of brightness that suggested rotation, an irregular surface, perhaps tumbling end over end. Some likened it immediately to Oumuamua's spin. Others cautioned patience. Still, the sense of familiarity stirred. Had we seen this story before, with new details emerging to deepen the mystery? The first nights of observation framed the question, but did not answer it. What exactly was 3I Atlas? A frozen shard from a shattered exoplanet? A fragment of cometary debris stripped from a distant system? Or something beyond even these natural guesses? The discovery itself, though celebrated, carried with it the weight of strangeness. Already, the world's astronomers sensed that this was not merely another rock catalogued in the endless lists of the solar system. It was a message written in silence, carried across interstellar space, awaiting its unraveling. The recognition of 3I Atlas did not exist in a vacuum. Each interstellar visitor carried with it the memory of its predecessors, a lineage of riddles written against the backdrop of the stars. When astronomers labeled this new arrival 3I, the implication was not simply numerical. It was a reminder of a fragile chronology that began only 7 years earlier, when the first known interstellar object 1I Oumuamua had sliced silently through our solar system. Oumuamua's very name, chosen from Hawaiian, meant a messenger from afar arriving first. And what a messenger it had been. Discovered in October 2017, it carried the profile of a long, tumbling shard, accelerating as if nudged by something more than gravity, yet without the visible coma of a comet. Its brightness flickered as it spun, hinting at shapes elongated like a shard of glass or flattened like a pancake. The scientific community debated with unease. Was it ice venting invisible hydrogen? Was it a broken fragment from another system's planetesimal belt? Or, as some whispered, was it something engineered, a sail drifting on starlight? In the end, Oumuamua slipped away too quickly, leaving only speculation in its wake. 2 years later came 2I Borisov, named for the amateur astronomer who first glimpsed it. This one looked at least superficially, like a more familiar comet. It grew a tail, it shed gases, it bore the hallmarks of frozen volatiles, sublimating under the Sunday. Yet even Borisov had strangeness in its composition, unusually pristine, unweathered by the processes that had long reshaped solar comets. It seemed an untouched relic, a fossilized capsule from some other star's cold nursery. Into this short history now entered 3I Atlas, the third visitor, the third clue in a puzzle we scarcely yet understood. What did it mean that, for the first time in history, humanity had seen not one, not two, but three objects from other stars in such a brief span? Were these sightings the product of improved detection methods, our telescopes finally sensitive enough to notice what had always been there? Or was there something unusual in the timing itself, a clustering, a cosmic rhythm suddenly revealing itself? Atlas differed from both predecessors in crucial ways. Unlike Borisov, it showed little to no evidence of a tail. Unlike ʻOumuamua, its brightness did not fluctuate wildly, though it whispered hints of irregular rotation. Its spectral qualities did not clearly match either icy comet or stony asteroid. It seemed, instead, to hover in an uncertain middle ground. Yet what united all three visitors was their defiance of the familiar. In ʻOumuamua's case, the defiance was dynamical, an unexplained acceleration. In Borisov's case, chemical purity. And now, with Atlas, it was something subtler, a path threading close to Mars, a silence in its interactions, a stubborn resistance to categorization. Astronomers began to place Atlas within the lineage, not as a mere addition, but as a progression. ʻOumuamua had opened the door to radical speculation. Borisov had reassured some by presenting a more recognizable face, even while troubling others with its pristine composition. And Atlas seemed to balance on the knife edge between the two, carrying the unease of ʻOumuamua and the understated composure of Borisov, while cloaked in its own particular silence. If there was a narrative forming, it was this: humanity was no longer alone in its solar solitude. Visitors came, rare, yes, but real. They crossed the abyss from distant stars and revealed themselves, briefly, before vanishing again into the eternal dark. In each, we saw not only alien stone or ice, but mirrors of our own questions about origin, about meaning, about the possibility that something beyond natural chance threaded their appearances together. And so the lineage deepened. 1, 2, 3, ʻOumuamua, Borisov, Atlas, each bearing its own secret, each resisting full comprehension. The universe was not merely silent emptiness, it was sending us riddles, one by one, to see if we could listen. Numbers have always been the astronomer's most trusted lantern. They pierce the dark, strip away illusion, and anchor celestial mysteries in the clarity of calculation. When 3I Atlas first revealed itself, those numbers were run quickly. Apparent magnitude, orbital inclination, eccentricity, perihelion distance, and velocity relative to the Sunday. Yet instead of reassuring familiarity, the figures whispered of strangeness. Its speed was the first alarm. Ordinary comets and asteroids bound to the Sun enter our inner solar system with velocities shaped by long ellipses, predictable arcs that obey Kepler's laws. But Atlas moved faster than that, too fast to have been captured by the solar system's gravity, and its eccentricity rose above unity, the unmistakable hallmark of an unbound orbit. This was not a child of our Sun, but a drifter from another star. Brightness, too, gave pause. For an object of its estimated size, Atlas seemed unusually dim. Its albedo reflectivity was lower than expected, swallowing light rather than scattering it. Some suggested this was a cloak of carbonized dust, baked by countless eons between stars. Others pointed out a subtler oddity. Its dimness did not vary with solar heating in the way a comet's would. As Atlas drew nearer to the sun, it did not erupt in jets of vapor, nor did its tail unfurl like a banner. Instead, it glided with a quiet refusal, keeping its surface sealed, as if resistant to our star's warmth. Even its orbit defied expectation. Its inclination was steep, tilted at an angle foreign to the solar system's orderly disk. It cut across the planetary lanes, ignoring the choreography of worlds, as though it carried its own map written by another Sunday. And then there was the sheer improbability of its path, not only cutting inward, but doing so in such a way that its closest approach would align astonishingly near Mars. Some called it coincidence, the cosmic lottery of random trajectories. Others noted how vanishingly small such probabilities seemed. Why Mars? Why this particular moment in the age of telescopes? Was it mere chance, or did some deeper resonance lie at work, gravitational nudges from stars long forgotten, or the unseen sculpting of galactic tides? Scientists accustomed to the elegance of prediction found themselves unsettled. For centuries, orbital mechanics had been a domain of certainty. One needed only Newton's laws, a few measurements, and the paths of worlds could be mapped centuries into the future. Yet Atlas seemed to slip through this framework. Its motion was not inexplicable. Gravity could still describe it, but its defiance of cometry norms, its refusal to brighten, and its improbable passage by Mars combined into something more than odd. It was as though the numbers themselves carried a faint dissonance, like an instrument just slightly out of tune. What made this unsettling was not simply the anomaly, but its echo of the past. Astronomers remembered the puzzling acceleration of ʻOumuamua, which could not be fully explained by comets outgassing. They remembered the pristine chemistry of Borisov, and now they watched Atlas glide in silence, dim, secretive, and geometrically improbable. Each new figure entered the ledger of strangeness, as though the universe were methodically building a pattern of disobedience. The deeper the calculations went, the stronger the tension grew. Computer models tried to simulate the body's shape from its faint light curve, but the answers were inconclusive. Long and thin, flat and wide, tumbling slowly, no single geometry seemed to fit all the data. Even its spin remained elusive, masked by the faintness of its light. Atlas resisted classification, wearing its ambiguity like armor. In science, expectation is often a quiet prison. When a comet enters, it should brighten. When a body rotates, it should flicker predictably. When trajectories are random, they should rarely intersect planetary orbits so closely. And yet Atlas denied each expectation in turn. Its very presence seemed designed to provoke the question, was this merely a fragment of nature, or was nature here conspiring to deliver a deeper mystery? The astronomers wrote their reports, submitted their figures, and published their plots. But beneath the graphs and numbers lay an unspoken unease. Something about 3I Atlas did not fit. And in science, when something does not fit, the story is only just beginning. Mars is no stranger to visitations. For centuries, its red glow has stirred imaginations, inspiring tales of canals, alien civilizations, and ghostly gods. Yet what unfolded in 2024 was no storybook fantasy. The calculated path of 3I Atlas drew it, improbably, toward the orbit of the red planet itself. For astronomers who ran the models, the numbers were stark. Its trajectory would not simply brush the solar system, it would pass close, startlingly close, to Mars. This was more than a celestial curiosity. Orbital mechanics painted a scenario in which Atlas would slip past the sun's warmth, arc inward, and intersect the Martian neighborhood with unnerving precision. To planetary scientists, this was like watching a cosmic arrow streak across a target, its course predetermined long before humanity ever learned to chart such paths. What were the odds that an object born in some unknown stellar nursery, traveling for untold millions of years, would align its journey with the orbit of the very world humanity dreams of colonizing? Mars had long been a mirror of our ambitions, a place where robotic explorers wander, where human footprints are promised but not yet delivered. And now, into this theater of human aspiration, came an interstellar messenger, uninvited and unannounced. Its closest approach distance was calculated with unease, far enough to spare any collision, yet close enough to rattle the imagination. Astronomers spoke cautiously of gravitational influences, of the way Mars might tug faintly on Atlas as it passed. Some speculated that the flyby could slightly alter its trajectory, a tiny nudge written into the mathematics of celestial mechanics. But others whispered of something more profound, a coincidence too sharp, too uncanny to ignore. As the date of the passage drew near, observatories turned toward Mars's skies, anticipating both a scientific opportunity and a symbolic encounter. Spacecraft already orbiting Mars, the silent watchers like MAVEN, Mars Reconnaissance Orbiter, and even the newer relay satellites were primed to record data. Telescopes on Earth sharpened their eyes. The stage seemed set for a grand revelation, a close interstellar flyby near another planet, observed by both Earth and Martian instruments, an unprecedented alignment in the history of astronomy. Yet alongside the thrill was unease. What if Atlas revealed something unnatural? What if its trajectory bent inexplicably, as Oumuamua's once had? What if it did more than glide past? What if it interacted? These questions hung in the air, spoken softly in research halls, scribbled in speculative notes never meant for publication. The sense of waiting grew palpable, the kind of silence that grips before a storm. Mars itself offered a poetic symmetry. Here was the planet most associated with war, conflict, and omen in human history, now hosting a passage of a stranger from beyond the stars. Astronomers could not help but feel the weight of the symbolism, even as they grounded their work in physics. The approach of Atlas near Mars was not merely another celestial event, it was the tightening of a thread, a convergence of chance and cosmic timing that stirred both scientific hunger and human imagination. For millions of years, Atlas had traveled untouched, its course written by the geometry of stars and the currents of the galactic tide. Now, in the tiny flicker of human history, it brushed the domain of Mars, our chosen frontier. This alignment felt like a riddle spoken in cosmic language, daring humanity to interpret its meaning. The date of encounter approached, instruments primed, telescopes steady. But as with so much in this story, what should have been a moment of luminous revelation would instead descend into silence, leaving behind not clarity, but deepening shadows. The encounter itself should have been luminous with data. As 3I Atlas slipped past the orbit of Mars, astronomers expected the ordinary signatures, fluctuations in light curves as its geometry revealed itself, subtle gravitational deflections measurable against the steady backdrop of stars, perhaps even faint activity as the sun's heat reached deeper layers of its alien crust. Yet what followed was not revelation, but something more unsettling, a silence where there should have been sound. At the time of closest approach, observers anticipated a crescendo of information. Telescopes were pointed, spacecraft instruments readied, orbital relays calibrated to monitor every flicker. Yet, as Atlas threaded its way past Mars, no such crescendo came. Data streams that should have grown richer faltered instead. Signals flatlined. The object's brightness, already faint, seemed to vanish into the background noise. As if on cue, the trail went dark. What could explain this absence? Dust activity would have brightened the object, not extinguished it. Rotation should have produced periodic flickering, not disappearance. And if the body had simply continued onward, its reflected sunlight should still have been visible. Yet the official records noted a sudden drop in detectability, a strange erasure at the very moment of closest approach. For the public, little was said. NASA issued no press release, no detailed update, no triumphant declaration of interstellar science unfolding. Instead, silence radiated outward from official channels. Observatories that had published early reports now grew cautious, their updates rare, their statements couched in ambiguity. The word lost began to appear in internal notes, lost not in the sense of destroyed, but in the sense of untraceable. Speculation, meanwhile, surged in the shadows. Had the instruments themselves failed, coincidentally, at the critical moment? Was the object darker than expected, coated in material that absorbed sunlight so completely it blended into the black? Or was something else at work, an intentional masking, an absence engineered rather than accidental? For planetary scientists, the absence was its own data point. Silence in astronomy is never empty. A missing signal, a vanished light curve, a sudden blackout, all are as meaningful as positive detections. The very act of disappearance, particularly so near to a planet humanity watches with such intensity, carried a weight that no equation could soften. Mars itself offered no immediate clues. Orbiters did not report anomalous debris or atmospheric effects. Rovers on the ground, blind to the sky except in narrow bands, recorded only the ordinary passage of Martian days. Yet the fact remained: the interstellar visitor had passed by, and the instruments tracking it had failed to deliver the expected record. Some whispered of censorship, of deliberate silence. Others insisted the universe itself had intervened, cloaking Atlas in mystery as it passed the red planet. What all agreed upon was the same: a once-in-history event had occurred, and humanity's record of it was blank, as though the cosmos had deliberately erased its footprints. The silence was not merely the absence of sound, it was the presence of something else, something heavy, charged, and unresolved. The near-Mars encounter of 3I Atlas was not remembered for the data it yielded, but for the silence it left behind, a silence that would only deepen as the story unfolded. In the days that followed, astronomers combed obsessively through the fragments of data that remained. Though the primary streams had faltered, faint echoes lingered in scattered observations, scraps of light curves captured at the edges of telescopic fields, spectral hints smudged into the background noise. Like whispers in a crowded room, these fragments carried the uneasy sense of meaning, half lost, half concealed. What did they reveal? At first glance, almost nothing. Irregularities, fluctuations too faint to trust. But when layered and compared, patterns began to emerge. The brightness of 3I Atlas, faint as it was, had not been steady. It rose and fell subtly, as though its surface reflected light in complex geometries. Astronomers spoke carefully of rotational modulation, an object tumbling, exposing facets that gleamed for moments before vanishing into darkness. Yet there was something stranger still. The timing of those fluctuations did not align cleanly with expectations for a simple rotating body. Instead, there appeared to be interruptions, periods where the light curve flatlined, as though the object turned not merely irregular, but deliberately obscured. Instruments at one observatory noted a sudden dimming, inconsistent with geometry alone. Another reported spectral readings that hinted at faint absorption bands, inconsistent with the carbonized dust or ice crusts that typically blanket such wanderers. Was this a signature of exotic material? Some hypothesized metals oxidized by eons of interstellar bombardment. Others dared to suggest surfaces engineered, not natural reflective panels, irregularly aligned, tumbling in silence. Though such words rarely reached the public, they circulated in private discussions, couched in conditional phrases but weighted with unease. Compounding the strangeness was a secondary anomaly. A few instruments reported noise patterns in their detectors, irregular static spikes coincident with Atlas's closest approach to Mars. These could easily be dismissed as electronic artifacts, cosmic rays, or chance, yet the timing drew suspicion. To those inclined to speculation, it seemed as though Atlas carried with it not only reflected sunlight, but some other signal, faint, buried, and inscrutable. What unsettled scientists most was not the clarity of these whispers, but their ambiguity. They resisted definitive interpretation. The data could be dismissed as noise, yet it also invited imagination. And in the silence left by official statements, imagination filled the void. The whispers became the first fracture in the story. A body expected to be inert, dim, and ordinary instead displayed fluctuations that hinted at hidden structure. A silence that should have been mundane grew heavy with implication. Were these merely artifacts of overstretched instruments, or genuine signs that Atlas bore features unknown to natural comets and asteroids? Astronomy thrives on certainty, on data clean enough to constrain models. But here, with Atlas, certainty dissolved. All that remained were whispers in the dark, hinting that beneath the silence of its Mars encounter, something stranger than expected lingered, just out of reach, beyond the edge of resolution. Then came the moment that turned unease into alarm. It began as a technical note, buried deep in observatory logs. Instruments tracking 3I Atlas had gone offline. At first, this was explained away routine glitches, network interruptions, the kinds of failures common in the fragile chain of modern astronomy. But as hours stretched into days, a pattern emerged. Multiple observatories, scattered across continents, reported sudden dropouts. Data streams that should have traced Atlas's path beyond Mars simply ceased. The word shutdown entered conversations not of the object itself, but of the eyes watching it. Automated telescopes stopped recording. Arrays failed to upload data. Even the Deep Space Network, whose vast radio dishes listen across the solar system, recorded anomalies at the very moment signals should have been strongest. Was this coincidence? Perhaps. Technical systems are fragile, and their failures rarely align with poetic timing. Yet here, across multiple institutions, the failures converged. The very act of watching seemed to unravel, as though the interstellar object carried with it a shadow that silenced instruments in its wake. Astronomers scrambled to restart systems, to recalibrate sensors, to reclaim the trail, but the trail remained lost. 3I. Atlas had not disappeared from the sky entirely. It was still there, faint and distant, but the systematic ability to track it with precision collapsed. Observations became sporadic, fragmentary, insufficient to reconstruct its exact path. The object was, in the most chilling sense, slipping into invisibility. For those who remembered ʻOumuamua, the sensation was eerily familiar. That object, too, had departed too quickly, its mysteries unresolved. But with Atlas, the vanishing felt engineered not by the cosmos, but by circumstance. Why did instruments falter at precisely the moment of closest encounter? Why did redundancy fail across nations and continents in ways that left no comprehensive record? The scientific community bristled. Some demanded transparency. Were agencies concealing anomalies too unsettling to disclose? Others maintained that the failures were innocent, statistical noise in the machinery of observation. Yet silence grew heavier from official channels. NASA issued no detailed account of why streams faltered. ESA offered none. The public heard little beyond the vague phrase, tracking difficulties. Within research circles, unease hardened into a phrase rarely spoken aloud, but often thought, the shock of shutdown. It was not only the object that had unsettled astronomers, but the sudden erasure of the very tools meant to illuminate it. For science, the unbroken gaze is everything. to lose that gaze at the moment of deepest mystery was not merely unfortunate, it was catastrophic. And so, the story of 3i Atlas shifted again. It was no longer only about an interstellar visitor brushing past Mars. It became a story of silence upon silence, the silence of the object itself, resistant to ordinary cometary activity, and the silence of our instruments, collapsing at the moment of greatest need. In that void, fear took root. For if an object can pass so close, carry so many anomalies, and leave us blind at the critical moment, what else might wander into our system, unseen, unrecorded, and unexplained? Silence in science is rarely neutral. When the skies fall quiet, the human mind grows restless, weaving questions from the gaps. And in the wake of 3i Atlas's strange disappearance into the background, the most unnerving silence was not cosmic, but human. For NASA, the institution that for decades had made itself the custodian of celestial knowledge, spoke little, too little. In the days following the shutdown, no press release emerged. There was no technical bulletin explaining the failures, no celebratory analysis of data collected at closest approach, no clarifying words for a public hungry for answers. Instead, there was a kind of institutional hush, a refusal to amplify what had just occurred. At best, vague reassurances appeared in scattered comments. Tracking difficulties, loss of data, ongoing investigation. At worst, nothing at all. This silence, more than the object's own mystery, ignited unease. For every major discovery of the heavens had usually been met with proclamation, images, plots, explanations, even when incomplete. ʻOumuamua had been celebrated openly, debated publicly. Borisov, too, had been welcomed as a natural cometary cousin from afar. But Atlas, despite its equally historic nature, seemed cloaked in official reticence. Why? Some suggested a desire to avoid premature speculation. After ʻOumuamua's whirlwind of theories, comet, asteroid, hydrogen iceberg, solar sail, NASA might have wished to sidestep the circus of controversy. Better silence than reckless conjecture. Others muttered about embarrassment, the unwillingness to admit the scale of system failures at the very moment of opportunity. Yet in the absence of words, darker thoughts flourished. Was there something discovered that was too unsettling to share? Something that, if spoken, would ignite panic or conspiracy on a global scale? Public trust in silence is fragile. The internet filled with its own narratives, hidden artifacts, alien technologies, government cover-ups, even claims that Atlas had docked with Mars itself. None were grounded in evidence, yet all thrived in the vacuum left by institutional restraint. Silence is never empty. It is a canvas upon which imagination paints. Among scientists themselves, the frustration grew sharper. For many, this was the chance of a lifetime to study an interstellar visitor during a planetary encounter. Yet, the collective effort fractured. Observations remained scattered, privately held, cautiously shared. Without centralized communication, the sense of global cooperation faltered. In the end, it was not what NASA said that resonated, but what it did not. Silence had become its own declaration, a statement louder than words. To many, that silence seemed deliberate, measured, and heavy with implication. And so, the story of Atlas slipped further from scientific certainty and deeper into the realm of whispered speculation, where silence itself became the loudest clue of all. In the absence of clarity, memory became a guide. Astronomers, historians, and dreamers alike began to revisit the earlier anomalies, those first two interstellar visitors whose mysteries had never been fully laid to rest. The silence around 3i Atlas felt eerily familiar, as though it echoed an unresolved chord struck years before. ʻOumuamua was the first shadow. Discovered in 2017, It entered the solar system like a sliver of glass, racing faster than any local comet and tumbling in ways no asteroid had ever been seen to tumble. Most unsettling of all was its acceleration, a tiny but undeniable boost as it departed the Sun, unexplained by ordinary physics. Comets gain such boosts from jets of vapor, yet ʻOumuamua bore no tail, no visible coma, no outgassing. The anomaly split the scientific world. Some argued for hidden hydrogen ice, sublimating invisibly. Others claimed exotic shapes and materials could explain it. And then there were those who suggested the unthinkable, that it might be an artifact, a fragment of technology adrift between stars. Then came 2I Borisov, 2 years later, a more recognizable comet, at last spraying gas and dust, producing the tail and coma astronomers expected. Yet even Borisov carried strangeness. Its chemistry was startlingly pristine, richer in carbon monoxide than most solar comets, as if it had been preserved in the cold of interstellar space without the slow weathering our comets endure. To some, it was the cleanest glimpse yet of alien planetary nurseries. To others, it raised questions about why interstellar visitors seemed determined to arrive with quirks that unsettled theories rather than confirming them. And now, Atlas, not elongated and accelerating like ʻOumuamua, nor icy and cometary like Borisov. Instead, something quieter, more elusive, an object that dimmed rather than brightened, that cut a path improbably near Mars, and that seemed to vanish into observational silence at the very moment of greatest scrutiny. Together, these three formed a trilogy of unease. Each had carried a puzzle, each had forced the scientific world into speculation, and each had departed without resolution. The pattern was becoming undeniable. Interstellar objects do not behave as expected. They arrive not as mere comets or asteroids, but as riddles that strain the frameworks of astronomy. In the archives of discussion, one phrase began to circulate: echoes of past anomalies. For what Atlas presented was not wholly new, but a continuation, a resonance of mysteries first stirred by its predecessors. ʻOumuamua had challenged our understanding of motion. Borisov had challenged our understanding of composition. Atlas now challenged our capacity to even observe. What linked them? Was it simply coincidence that the first three known interstellar visitors all bore profound strangeness? Or was there something about their very nature, about the environments from which they came, that guaranteed they would defy us? The echoes deepened the dread, for if each interstellar object was not simply a body of ice or rock, but a messenger of anomalies, then the universe itself seemed to be sending us lessons wrapped in mystery. And if we could not interpret ʻOumuamua, nor Borisov, nor now Atlas, what did that say about our readiness to understand the larger cosmos? The more astronomers examined the path of 3I Atlas, the more its improbability pressed in. To glimpse an interstellar object is rare enough, so rare that in the entire history of astronomy, only 3 had been confirmed. That one of them should sweep so near to a planet was not impossible, but the odds were staggering. Mars, with its thin orbit around the Sun, presented a cosmic bullseye struck by a dart that had travelled for millions of years from the void between stars. What unsettled scientists most was not merely the improbability, but the implications. For orbital mechanics is a realm of precision. Trajectories can be traced backward and forward, reconstructed with exquisite fidelity. The models showed clearly that Atlas's path had been shaped not by encounters within the solar system, but by forces long before, out in the deep galactic tide. Somewhere, long ago, in a system we cannot name, the object was ejected, hurled into the darkness. Its path through the Milky Way carried it uncounted light years until, improbably, it intersected with ours and, more improbably still, brushed the orbit of Mars. Some dismissed this as chance, a roll of cosmic dice that humanity happened to witness, but others could not shake the feeling of design, or at least of resonance, as if the cosmos itself were orchestrating moments of contact, aligning trajectories to brush our awareness, to remind us of our fragility in the scheme of interstellar space. What deepened the sense of impossibility was the scale of the anomaly. Atlas was not behaving like an ordinary comet or asteroid. It resisted brightening. It resisted detection. It passed in silence where noise was expected. To planetary scientists, this silence was more than peculiar. It was terrifying. For if such an object could glide unseen so close to a world, what else might drift through the solar system without our notice? What other wanderers might slip past the gaze of telescopes, carrying with them energies or intentions unknown? The threat was not immediate in the sense of collision. Orbital models suggested no impact with Mars, and certainly none with Earth. But the deeper threat was epistemic, a shaking of the framework itself. Science thrives on predictability, on the assurance that celestial bodies obey laws we understand. Atlas, by contrast, whispered of disobedience. Its dimness, its improbable trajectory, its vanishing, all suggested a reality less tidy, less controlled than textbooks promise. To some, this was exhilarating, the possibility that nature still held secrets vast enough to unnerve us. To others, it was destabilizing, a reminder that our carefully constructed maps of the cosmos may be incomplete. In conferences and private notes, scientists used words they rarely dared speak in public: paradigm, breaking, unclassifiable, dissonant. For the public, the danger lay in the unknown, an interstellar body sweeping silently past Mars, slipping into darkness, its observers silenced. This carried the texture of omen, not discovery. To philosophers and poets, it seemed a cosmic mirror held up to humanity, reflecting both our hunger to know and the limits of our knowing. To scientists, it was a hard truth. The universe is not required to be legible. And in Atlas, it had presented a reminder that some mysteries arrive not to be solved, but to confront us with our own uncertainty. The scale of impossibility, then, was not just statistical, but existential. It was not merely unlikely that Atlas passed so near to Mars, it was profoundly destabilizing. For in that closeness, in that silence, and in that vanishing, it forced us to ask whether our science is prepared for the strangeness that drifts between the stars. When the trail of Atlas grew faint, and silence replaced the chorus of expected data, attention turned backward into the dusty shelves of human memory. If the present could not explain this object, perhaps the past could whisper clues, and so began the search through archives. Old sky charts, historical records, myths of strange wanderers glimpsed before the modern telescope was even conceived. Ancient astronomers, with naked eyes and rudimentary instruments, had recorded comets as omens, visitors in the sky that appeared without warning and left without reason. In Babylonian tablets, one finds careful sketches of streaking lights, annotated with meanings of war and famine. In Chinese chronicles, meticulous observers logged every irregular star, often noting broom stars that swept across the heavens. Could some of these, lost in antiquity, have been interstellar passers-by mistaken for ordinary comets? The idea was tantalizing. After all, ʻOumuamua and Borisov proved that such visitors do exist, rare but real. Might history hold forgotten sightings of others, unrecognized as such, dismissed into the general catalogue of comets? Astronomers began to re-examine orbital reconstructions of historical comets, seeking anomalies, eccentricities greater than 1, or trajectories that refused solar binding. A few candidates emerged, whispers from centuries ago, though the data was too poor to be certain. Beyond written records lay myth itself, Cultures across the world spoke of wandering stars, sudden lights, heavenly messengers. In Norse sagas, omens of fire coursing through the night sky were said to herald upheaval. In Polynesian traditions, star travelers were linked with voyaging gods. Even in Mesoamerican codices, the sudden arrival of fiery objects in the heavens was linked to cosmic cycles of destruction and renewal. Might these myths conceal distorted memories of interstellar interlopers, their singular strangeness burned into cultural memory? Some scientists rejected such speculation, dismissing it as romantic projection, yet others admitted a quiet curiosity. After all, 3I Atlas had passed so near Mars that coincidence strained credulity. Was it unthinkable that similar visitors, across millennia, might have brushed Earth or its neighboring worlds, leaving impressions too fleeting to catalogue, but too strange to forget? Even within modern archives, peculiar echoes remained. A few comets observed in the 19th century bore peculiar paths, their eccentricities calculated near the threshold of hyperbolic. Some were lost after only brief observation, never seen again, their identities unresolved. Could one or more of these have been true interstellar wanderers, missed because humanity lacked the tools to discern their origins? In the face of Atlas's silence, these archival whispers gained new weight. If the object refused to yield its secrets in the present, perhaps its kind had spoken before, through the cryptic language of myth and incomplete observation. The possibility stirred a haunting thought. Perhaps interstellar visitors have brushed past our skies many times across human history, unnoticed or misinterpreted, their presence woven into stories of gods and omens rather than equations and data. And if that were true, then Atlas was not an anomaly but part of a hidden lineage stretching back beyond science itself. Each visitor, a fleeting messenger, brushing against human awareness, never long enough to explain itself, but always long enough to unsettle. The search through archives offered no definitive answers, but it seeded a deeper unease. Perhaps we are not encountering the first of these wanderers. Perhaps we are simply the first to name them for what they are, and the mystery, far from beginning, is far older than we have ever realized. Light is the astronomer's language. Every photon that journeys from a distant object carries a signature, a fingerprint of its origin. Through spectrographs, scientists pry open those photons, stretching them into rainbows laced with dark absorption lines, each one whispering of atoms, molecules, and the conditions in which they dwell. For 3I Atlas, the hope was simple. If it would not reveal itself in brightness or in activity, then perhaps its spectrum would betray its nature. The first spectra, hurriedly captured before its passage by Mars, were frustratingly faint. A dim curve, faint lines barely distinguishable from noise. Yet as teams across the world compared notes, subtle patterns emerged. Atlas reflected light in ways that did not match the icy volatility of Borisov, nor did it echo the rocky neutrality of asteroids. Instead, its spectral profile wavered between categories, as though it belonged to neither. Some astronomers noted shallow absorption bands, hinting at carbonaceous material, the residue of eons adrift in interstellar space. Others saw suggestions of silicates, minerals common in rocky bodies. But there was a strange flatness in certain regions of the spectrum, an absence where activity should have been. When a comet nears the Sun, water and other volatiles erupt into vapor, producing telltale spectral lines, hydroxyl radicals, cyanides, fragments glowing under solar radiation. Atlas showed none of these. Its silence extended even into its chemistry. And yet, anomalies crept in. At one observatory, faint infrared data suggested a reflective patch, possibly metallic in nature. Another recorded a peculiar sharpness in one band, a spike that resisted interpretation. Were these mere artifacts of weak data or glimpses of something unusual in its surface composition? The light curve itself, charted across days, hinted at irregularity. A body rotating should brighten and dim in predictable rhythm. But Atlas's fluctuations carried interruptions, flat plateaus of silence amid tumbling variation. To some, this suggested facets, flat surfaces reflecting strongly, then vanishing. To others, it spoke of a body whose geometry was stranger than any simple rock or comet nucleus. In hushed tones, a few invoked ʻOumuamua again, that earlier interstellar visitor whose brightness flickered wildly as though it were elongated, shard-like, or even sail-like. Was Atlas echoing the same strangeness, but cloaking it more completely? Even the darkness carried meaning. For what Atlas did not show, no tail, no jets, no familiar chemical breath, was as telling as what it did. It was as though the object carried a shield, a resistance to the very sunlight that should have unraveled its secrets. Scientists remained cautious. Extraordinary claims require extraordinary evidence, and the spectral data was weak, barely above noise. Yet in the silence of NASA, in the absence of official interpretation, these spectral fingerprints took on outsized importance. Every irregularity became a clue, every faint spike a mystery. The nature of its light, or rather, its refusal to shine in familiar ways, became the essence of its enigma. Atlas did not announce itself in bright cometary flares. It whispered instead in muted rainbows, partial fingerprints, spectral hints that seemed to vanish just when they were most needed. Like a figure half seen through fog, it revealed enough to stir questions, and then cloaked itself once again in silence. For those who longed for answers, it was infuriating. For those attuned to mystery, it was profound. The cosmos had sent another visitor, and in its spectrum lay the unsettling reminder: not all light yields clarity. Sometimes, light itself carries silence. Trajectory is supposed to be a language of certainty. Gravity sculpts the paths of worlds and stones alike, writing their arcs in mathematics so exact that spacecraft can thread through planetary systems with pinpoint accuracy. Yet 3I Atlas, like its predecessors, seemed to move with a faint dissonance, a riddle written into its very speed. Calculations revealed the object's hyperbolic excess velocity, its speed relative to the Sun once freed of its gravitational pull. For ʻOumuamua, that number had already been unsettling, not only fast enough to mark it as interstellar, but subtly increasing as it left, as though an invisible hand had nudged it. Borisov, more obedient to the rules, had nevertheless travelled with a purity that raised its own questions. And now Atlas arrived, carrying echoes of both. Its orbit bore the unmistakable signature of an interstellar trajectory, but within its passage lay faint discrepancies, tiny mismatches between prediction and observation, whispers of velocity without reason. Some pointed to gravitational perturbations. Perhaps unseen nudges from Mars during its near pass had warped the track. Perhaps faint outgassing, invisible to spectrographs, supplied minute thrust. Yet the models resisted closure. The deviations, though subtle, did not align with the neat mathematics of either planetary influence or cometary jets. It was as though the object carried with it a vector of intent, a persistence that shrugged off the corrections of gravity alone. Such anomalies are dangerous in science. They invite speculation beyond what data supports. Still, comparisons to ʻOumuamua rose unbidden. There too had been acceleration without visible cause. There too had been debates of hidden hydrogen ice, of exotic ices sublimating invisibly, of solar sails pushed by photons. With Atlas, the mystery deepened. How many interstellar visitors must display such defiance before chance ceased to be a sufficient explanation? The silence around its Mars passage sharpened the suspicion. Had instruments not failed, perhaps we would have seen the acceleration in clearer detail, measured the deviations with certainty. Instead, astronomers were left with fragments, each one suggesting that Atlas's path was not wholly the child of gravity. Its velocity seemed to bear the fingerprint of something unacknowledged. To the cautious, the explanations remained natural, physics not yet fully mapped, chemistry not yet fully understood. To the bolder, the whispers grew darker. Was this motion engineered? Was Atlas not merely a shard of debris, but something that guided itself faintly, subtly, across interstellar space? No one could say with certainty. The deviations were too small to declare a violation of law, yet too consistent to dismiss outright. Like a whisper at the edge of hearing, they unsettled without proving. What was clear was this: velocity, the most reliable marker of origin, had become a source of unease. Atlas did not simply pass through, it passed with a persistence that defied neat closure. Its orbit was hyperbolic, yes. Its speed marked it as interstellar, yes. And yet, beneath those certainties lay a lingering unease that something about its motion carried more than gravity alone. The riddle of Atlas was no longer just in its silence, nor in its dimness, nor in its improbable alignment with Mars. It was in the quiet suggestion that its journey across the void was shaped by forces we had not yet named. A trajectory written not entirely by physics, but by something else, something that whispered through numbers, unprovable, undeniable, and deeply strange. When the models of trajectory strained against their limits, another possibility crept in, one older and more elusive than comets or asteroids. Perhaps Atlas was not guided by ordinary forces at all. Perhaps its path was sculpted by something hidden, something unseen yet powerful, the invisible architecture of dark matter. For decades, astronomers have known that galaxies rotate too quickly to be explained by visible mass alone. The outer stars, instead of trailing sluggishly, whirl at speeds demanding unseen gravity. Thus was born the hypothesis of dark matter, an invisible halo, outweighing visible stars and planets, whose presence is felt only through its pull. If such unseen mass shapes galaxies, might it not also nudge a lonely interstellar traveler? Imagine Atlas drifting for millions of years through pockets of uneven dark matter, its path imperceptibly warped by currents of invisible gravity. By the time it reached our solar system, its trajectory would no longer be a simple line from a forgotten star. It would be a palimpsest, a record of hidden encounters with the unseen scaffolding of the cosmos. Could its improbably close passage near Mars, then, be the echo of invisible structures we cannot yet map? Some theorists suggested local concentrations of dark matter streams or filaments passing through the solar neighborhood. These could tug subtly on interstellar bodies, bending them into courses that appear improbable when calculated under visible mass alone. Others speculated that dark matter might interact weakly not just through gravity but through exotic forces, imparting velocity shifts faint enough to hide within measurement error, yet strong enough to accumulate over eons. Yet this explanation carried its own strangeness. For if Atlas bore the fingerprints of dark matter, it would mean we had glimpsed, indirectly, the influence of a substance that remains one of the greatest mysteries of physics. It would mean that the silence of Atlas, its refusal to conform, was itself a message written by the dark cosmos, reminding us that most of reality lies unseen. The idea unsettled many, for dark matter is usually considered only at galactic scales, not planetary ones. To invoke it here seemed speculative, even reckless. But science thrives on tension between caution and imagination. The silence of NASA, the blackout of instruments, the peculiar deviations all gave space for whispers of explanations beyond the ordinary. And dark matter, that eternal ghost of physics, was one of the whispers that fit. Perhaps Atlas was a messenger not of another civilization, nor of engineered intent, but of the cosmos itself, an accidental probe from the dark framework holding galaxies together. Its trajectory may have carried the unseen handwriting of matter that does not shine, does not reflect, and yet binds the universe into its shape. If so, then the passage of Atlas near Mars was more than coincidence. It was a reminder that even in the immediate neighborhood of the Sun, forces we cannot see still sculpt the paths of stones. And perhaps, in this small anomaly, we had brushed against the hem of the greatest mystery of all, that most of the universe is invisible, and it is that darkness, not the light, that decides how we move. Beyond the reach of dark matter, beyond the weight of galaxies themselves, another possibility flickered in the minds of theorists. Perhaps Atlas, was being moved not by invisible mass, but by the restless foam of reality itself. In the deepest frameworks of physics, the vacuum is not empty, it seethes. It trembles with quantum fluctuations, ephemeral particles blinking into existence and vanishing, fields resonating with energy that cannot be silenced. Could such whispers of quantum space leave imprints on a drifting shard from another star? The idea sounds fanciful, yet it springs from serious tension in physics. The vacuum energy predicted by quantum field theory is staggeringly large, while the vacuum energy observed in cosmology, the dark energy driving the universe's acceleration, is staggeringly small. Between those two infinities lies a gulf of mystery. Some speculate that the vacuum may not be uniform at all, but laced with irregularities, fluctuations, or domains where the very fabric of space-time trembles differently. If Atlas had wandered through such regions in its interstellar journey, its motion might carry echoes of those fluctuations. Perhaps its velocity was not merely gravitational, but subtly nudged by vacuum energies seeping unevenly across space. Even here, within the solar system, some theorists wonder if quantum fluctuations could manifest as tiny, irregular forces on passing bodies undetectable in planets and moons, but perhaps measurable in small, fragile wanderers. Imagine Atlas as a feather drifting through a storm invisible to us, buffeted by pressures of the quantum vacuum. To our eyes, its trajectory looks improbable, even defiant. But to the vacuum itself, it is perfectly ordinary, the natural outcome of riding the turbulence of reality's hidden depths. There are precedents for such speculation. Physicists studying the Pioneer anomaly once considered whether small spacecraft were being nudged by unaccounted for physics, perhaps linked to quantum effects or modified gravity. Though later explained largely by thermal recoil, the memory of that anomaly still lingers, a reminder that the cosmos occasionally whispers in ways that appear to violate our laws. Atlas, silent and elusive, seemed another such whisper. Of course, the quantum vacuum is not easily invoked as a concrete cause. Its mysteries remain too vast, too poorly constrained. Yet within the silence left by missing data, the thought carried weight. Perhaps what Atlas revealed was not an alien artifact, nor a cometary shard, but a reminder that the ground of reality itself, the quantum fields from which all particles emerge, remains unsettled, alive, mysterious. In this interpretation, the strangeness of Atlas is not technological, nor even astronomical. It is metaphysical. It is the universe reminding us that space is not a void but a medium, not a backdrop but a restless sea. An interstellar wanderer, born of another star, carried across that sea for uncounted millennia, might naturally bear scars of turbulence we cannot yet map. And so, speculation broadened. Perhaps Atlas was not an anomaly in itself, but a messenger of deeper anomalies, a shard moved not only by the visible gravity of worlds, nor the invisible mass of dark matter, but by the ceaseless fluctuations of the vacuum. To study it, was to glimpse the possibility that reality is less solid, less stable than we imagine. The silence of its Mars passage, then, became symbolic, as though the universe had chosen not to give us easy answers, but to remind us instead that beneath every law lies mystery. Atlas moved as it did, because reality itself is not finished, not final. Its path was a reminder that even the vacuum hums with secrets. Theories of unseen mass and restless vacuums satisfied some, but for others, the silence of 3I Atlas suggested something more deliberate. The word no scientist wished to utter publicly slipped nevertheless into private conversations, into late-night messages, into cautious footnotes that stopped short of commitment, artifact. The hypothesis was not new. ʻOumuamua had ignited it years earlier. Its elongated shape, its unexplained acceleration, its refusal to display a comet's tail, all had prompted Avi Loeb and others to suggest that it might be a fragment of alien technology, perhaps a solar sail, drifting silently across interstellar space. The idea drew fierce criticism, not because it was impossible, but because it seemed reckless to leap so quickly from anomaly to intelligence. And yet, in the years since, the debate had never fully died. ʻOumuamua's mysteries had never been conclusively solved, leaving a space in which the artifact hypothesis lingered like an unresolved chord. With Atlas, the chord struck again. Its dimness, its irregular light curve, its improbable encounter near Mars, its sudden vanishing from instruments, all of it could, if one were willing to listen, be read as intention. Not proof, but suggestion. Not evidence, but shadow. Consider the possibility. An object not ejected randomly from a stellar nursery, but released, perhaps placed, upon a trajectory toward our system. Its silence, not the result of natural darkness, but of design materials chosen to absorb light, surfaces constructed to resist heating. Its fluctuations in brightness, not mere geometry, but facets of something structured, panels or sails tumbling across the void. Even its silence near Mars could be recast, not an observational failure, but an act of cloaking, of switching off a beacon when watched too closely. Of course, such speculation teeters on the edge of the unacceptable. The scientific method demands restraint, and the leap to intelligence is the most perilous of all. Yet in the absence of words from NASA, in the blank left by failed instruments, speculation flourished. If Atlas was natural, it was profoundly strange. If it was artificial, it was profoundly unsettling. What would it mean if it were artifact? It would mean that we are not the only civilization to touch the stars. That across the gulfs of interstellar space, someone or something has sent emissaries, or debris, or relics of journeys long past. It would mean that the silence of Atlas was not emptiness, but discretion, the choice of a presence not to reveal itself. And if it were artifact, why Mars? Was its passage mere coincidence, or a signal? Was it observing our robotic emissaries, the rovers and orbiters humanity has stationed on the red world? Was it reminding us, quietly, that we are not alone in aspiring to cross interplanetary gulfs? No proof was offered, no evidence could anchor the idea, but still the whispers spread. Alien artifact. The phrase lingered in the mind, heavy with both dread and wonder, for in Atlas, more than its predecessors, the silence itself seemed chosen, as if the object's most eloquent message was the refusal to be known. In that possibility lay both terror and awe. If natural, Atlas revealed how little we understand of interstellar debris. If artificial, it revealed how little we understand of ourselves, our place in a cosmos where intelligence may not be unique. Either way, the object's silence remained its most haunting feature, a blank space in which humanity's imagination painted futures both wondrous and fearful. Silence itself can be geometry. That was the unsettling phrase whispered by one astronomer as the data blackout of 3I Atlas was dissected. For in the realm of science, silence is not merely absence, it has form, structure, alignment. And the silence surrounding Atlas, its sudden dimming, its refusal to radiate, the synchronized collapse of instruments, felt less like a random failure and more like a pattern. Consider what unfolded. Telescopes on different continents, radio dishes spanning hemispheres, even orbital observatories, all reported gaps in their observations at or near the moment of closest approach to Mars. If this were coincidence, it was a brutal one, but to some, it seemed arranged, as though an invisible geometry had been drawn across the skies, excluding human eyes from a moment they were not meant to see. This gave rise to a chilling speculation. What if the shutdown was not an accident, nor a simple technical failure, but the result of interference? Not a signal broadcast to us, but a silencing of our own, cloaking, as some dared to call it. The idea that Atlas possessed the capacity to hide, to bend its detectability, to vanish not by moving but by altering how it interacted with instruments. The concept was not entirely without precedent. In physics, materials can be engineered to redirect waves metamaterials that bend light or scatter radar invisibly. If humanity has scratched at the surface of such technologies, could a civilization far older not have mastered them? Cloaking not in the theatrical sense of invisibility, but in the subtler, more effective sense of silence, appearing as background noise, vanishing into cosmic static. But there was another, more unsettling interpretation. Perhaps it was not Atlas that chose silence, but humanity itself. The geometry of data blackout could also suggest intentional suppression. Systems shut down, signals withheld, not by alien hands, but by human decisions. Was the silence around Atlas an act of protection, shielding the public from implications deemed too dangerous? Or was it the shielding of secrets, knowledge too provocative to release? Both readings were troubling. In one, the cosmos itself had erased our instruments, as though intelligence beyond ours had crossed paths with Mars and ensured no evidence remained. In the other, our own guardians of science had drawn the veil, creating a silence more deliberate than any cloaking field. The geometry of silence, then, was double-edged. It could mean we were brushed by technology not our own, or it could mean that humanity, confronted with strangeness, chose ignorance over revelation. Either way, the result was the same. The object passed, and the record was erased, leaving only fragments. Silence arranged itself like an architecture, enclosing us. The blackout was not just technical, nor just bureaucratic, it was symbolic. It reminded us that the greatest mysteries do not always announce themselves in fire or noise. Sometimes they arrive as absence, as missing frames in the cosmic film, as voids that force the imagination to do the work of vision. 3I Atlas left us such a void, a geometry of silence, a shape in absence, haunting because it might mean something far larger than we are prepared to face. Yet even when the great institutions faltered and silence seemed imposed, the cosmos is too vast to be contained by one nation's instruments. Astronomy is not the property of a single agency, but of a scattered humanity with eyes everywhere. And as 3I Atlas slipped into obscurity, other watchers, European, Chinese, private, even amateur, kept their vigil. From the Canary Islands, the European Southern Observatory turned its mirrors to the faint coordinates where Atlas should have been. Their results were fragmentary, blurred by atmospheric interference, but they reported glimmers, occasional detections that flickered just above the noise floor. In China, the enormous fast radio dish, usually dedicated to pulsars and fast radio bursts, swept the skies for any anomalous emissions. Officially, nothing unusual was reported, though whispers emerged of unexplained transients coincident with the object's path. Meanwhile, smaller observatories and amateurs contributed in unexpected ways. A telescope in South Africa, part of a sky monitoring project, recorded faint streaks on a handful of frames. In Eastern Europe, a dedicated group of sky watchers traced fluctuations in brightness that seemed to echo the irregular signatures noted before. Their work lacked the precision of NASA's great arrays, but it offered one thing the silence could not: continuity. Even private ventures entered the pursuit. The rise of commercial space telescopes, funded by billionaires, universities, and networks of citizen scientists, meant the object could not be completely hidden. Though their instruments lacked the reach of the James Webb or Hubble, they nonetheless offered independent confirmation. Atlas had not vanished. It remained faint, erratic, but detectable. These decentralized efforts painted a portrait very different from the official silence. Atlas had not ceased to exist. It had not departed without trace. Instead, it had become a ghost visible only in fragments, detected not in steady signals but in whispers scattered across the globe. This mosaic of faint traces carried with it profound implications. If the object was truly cloaking itself, it had failed, at least partially, for the persistence of human curiosity pierced the veil. If, instead, the blackout had been human-made, the scattered detections proved that truth resists containment. The universe, after all, belongs to no government. And within those faint confirmations lay a haunting reassurance. Atlas was still there, gliding silently past the orbit of Mars, on its way back into the abyss between stars. It had not burned up. It had not shattered. It had simply grown faint enough to escape all but the most determined eyes. The pursuit by other nations and private watchers revealed something more than science. It revealed a truth about humanity itself, that when silence descends from the top, voices rise from the margins. That when officialdom retreats, curiosity does not die. And so, Atlas remained a mystery, not confined to secrecy, but scattered among those who refused to let it vanish entirely. Even in silence, the stars resist erasure, and humanity, divided and flawed as it is, still finds ways to listen. The chase did not end with the scattered glimpses of smaller observatories. Instead, attention shifted forward toward the instruments that would soon redefine humanity's vision of the sky. For though Atlas was slipping away, other eyes, more powerful than any yet trained upon it, were preparing to open. Foremost among them was the Vera C. Rubin Observatory in Chile, an instrument unlike any before. Designed to scan the entire visible sky every few nights, Rubin's legacy survey of space and time promised to capture faint objects that would have been invisible to older surveys. Its 3.2 gigapixel camera, the largest ever built for astronomy, was not yet fully operational when Atlas made its passage, but its impending activation stirred hope. Future visitors like Atlas would not pass unseen. They would be catalogued, measured, tracked with relentless precision. The skies would be mapped not in fragments but in cinematic continuity. Then there was the James Webb Space Telescope, already operating far beyond Earth's atmosphere. Webb's infrared gaze could pierce through dust and distance, revealing chemical compositions and thermal signatures invisible to optical eyes. Webb had already glimpsed comets, exoplanets, and the faintest galaxies. An interstellar traveler like Atlas, if captured in time, could have been dissected with unprecedented detail. Though Webb's schedule and faintness constraints limited its ability to pursue this particular object, the precedent was clear. For the next wanderer, such tools would be waiting. Other projects loomed as well. The European Extremely Large Telescope, under construction, promised a mirror vast enough to resolve detail on alien worlds. China's expanding array of space telescopes, signaled an era where multiple powers could capture anomalies beyond Earth. Even private ventures, with aspirations of skywide monitoring, hinted at a future where no object, however faint, could truly vanish again. In this light, 3I Atlas became not merely a mystery, but a catalyst. Its silence revealed the limits of our present instruments. Its disappearance underscored the fragility of our gaze. Yet, in doing so, it sharpened the urgency of building better eyes. Humanity, stung by the loss, responded not with surrender, but with resolve. The irony was poignant. Atlas, in refusing to yield its secrets, may have ensured that its successors would not escape so easily. Future interstellar wanderers would pass beneath a surveillance network unprecedented in history. Their spectra, their trajectories, even their faint whispers of acceleration would be captured in exquisite fidelity. And yet, there was another, subtler irony. Even with the most advanced telescopes, what would we truly learn? Instruments can capture light and motion, but they cannot interpret intent. They can measure composition, but they cannot tell us whether a shard of rock is a relic of a shattered world or of a crafted machine. For that, humanity must do what it has always done: interpret, speculate, wonder. Still, hope remained. The sky was changing. With Rubin, with Webb, with the instruments yet unborn, the next Atlas would not slip so easily into silence. The cosmos would reveal itself more fully. And, perhaps, if the universe continues to send us such visitors, one of them will finally yield the truth that 3I Atlas kept hidden in its passing. Even as new telescopes promised sharper eyes, astronomers turned to another, older method of listening, not to light, but to the silent pull of gravity. For while photons can vanish into silence, the motions of planets are harder to erase. Gravity is the one universal conversation every mass must obey. If 3I Atlas had truly passed so near to Mars, then somewhere, hidden in the mathematics of orbits, its presence might still be recorded. The principle was elegant. Planets move with exquisite regularity, their positions charted and predicted with precision that rivals atomic clocks. If an interstellar body of measurable mass passed close enough, even without collision, it could leave behind a whisper in that precision, a slight perturbation in Mars's orbit, a faint tug on its moons, a deviation from prediction so small it could only be seen by the most delicate instruments. Already we had precedent. The discovery of Neptune itself had come not from direct sight, but from gravitational whispers in Uranus's orbit, tiny anomalies that betrayed an unseen presence. In the same way, the path of Atlas might be written not in light, but in the arithmetic of celestial motion. Teams began examining the tracking data of Mars orbiters, the signals from spacecraft relays, even the radio timing of the Mars Reconnaissance Orbiter and MAVEN as they circled the planet. Were there unexplained deviations in their telemetry, minute discrepancies between predicted and actual positions? The data was incomplete, some of it withheld, yet whispers emerged, slight anomalies, subtle drifts, hard to separate from ordinary noise. Were these merely the imperfections of instrumentation or the gravitational fingerprint of Atlas as it swept past? Beyond Mars, other approaches were considered. Earth's own radio tracking of spacecraft is so precise that it can detect accelerations of less than a millimeter per second. If Atlas exerted even the faintest influence, perhaps somewhere in the archives of the Deep Space Network, the tug was recorded without fanfare. Searching such records became its own quiet pursuit, a hunt for whispers buried in telemetry. But here, too, silence pressed in. Official channels offered little. Any anomalies remained unpublicized, tucked away in private calculations or reports that never surfaced. The absence of disclosure bred the same unease as before. Was the gravitational signature too faint to matter, or too unsettling to reveal? For gravity, is the one truth that cannot be hidden. If Atlas carried mass, it pulled. If it passed Mars, it left a trace. Whether that trace was measurable or merely theoretical, it meant the silence could not be total. Even if our instruments failed, even if data was withheld, the cosmos itself remembered. And so, astronomers spoke of gravitational whispers, not data sets, not light curves, but the possibility that the planets themselves had felt the presence of an interstellar visitor and carried its signature in their orbits. Perhaps one day, with better analysis, those whispers will be resolved into clarity. For now, they linger as another layer of unease, a reminder that Atlas passed not in absolute silence, but in a way that even the motions of worlds could not fully ignore. When the trail of direct observation fades, when light falters and instruments fall silent, science turns to its second language, simulation. In the digital halls of supercomputers, reality can be replayed, reconstructed, stretched into possibilities that the heavens themselves may never yield twice. And so, when 3I Atlas slipped into ambiguity, teams of physicists began to run scenarios not to solve the mystery outright, but to map the boundaries of the impossible. The simulations began with what was known: an object with a hyperbolic orbit, a perihelion that carried it uncomfortably near Mars, a light curve marked by faint irregularities, and a disappearance that corresponded with instrument failures. Into this framework, computers poured assumptions about density, about reflectivity, about possible compositions of rock, ice, or exotic volatiles. They spun out models of rotation, watching how virtual fragments might flicker in brightness as they tumbled beneath simulated sunlight. Some models matched partially. A shard of fractured carbon-rich rock could mimic the flat dimness. A tumbling irregular nucleus might explain the erratic light. Yet none explained the silence of gas, the absence of spectral fingerprints, the stubborn refusal to brighten near the Sunday. In scenario after scenario, ordinary comets betrayed themselves with visible jets. Atlas did not. The models failed to reconcile its quiet. Other simulations turned to its trajectory. By backtracking its orbit, researchers traced its path through the solar system, then farther into the galactic tide. Some runs suggested origins in the Perseus arm, others in the local bubble, a region of rarefied gas carved by ancient supernovae. In all scenarios, the timescales stretched into millions of years. Atlas was no newcomer. It had been traveling since before humanity's ancestors walked upright. And yet, here it was, grazing Mars as though its journey had been scripted for this moment. Then came the bolder models, the speculative ones. What if Atlas had been thinner, flatter, more sail-like, its motions influenced not by gravity alone but by the faint pressure of starlight? These simulations reproduced subtle accelerations, deviations like those seen in ʻOumuamua. Other runs imagined exotic ice, hydrogen or nitrogen that could sublimate invisibly, providing thrust without a visible tail. Such models fit in fragments, never in whole. Each left gaps, unanswered silences. And in some laboratories, whispers of more radical simulations emerged. What if Atlas was hollow? What if its density was too low for rock, too stable for ice? What if it was structure, not debris? Such models could, in principle, explain its silence, its dimness, its resilience near the Sunday. They could even account for the suggestion of facets in its light curve, as though panels or surfaces reflected selectively. But these models never left the realm of speculation, for to suggest them openly was to invite ridicule. The supercomputers churned for weeks, months, producing terabytes of scenarios. In the end, the result was paradoxical. Simulation proved that Atlas could be many things, But not everything at once. Every plausible explanation solved one puzzle while breaking another. Every reconciliation left something unsatisfied. And so, the simulations became their own mirror of the mystery. They revealed that the silence of Atlas was not a flaw in our instruments alone, but a flaw in our understanding. Nature had presented an object that sat at the border between categories: rock, yet not rock; comet, yet not comet; traveler, yet not wholly natural. In the glowing racks of supercomputers, humanity had run the cosmos through its finest algorithms, and still, Atlas refused to be explained. Its silence persisted, echoing even in the digital realm. For some mysteries, no model suffices. For some visitors, the most powerful simulation only proves how little we truly know. Every attempt to interpret 3I Atlas inevitably circled back to the laws that had long guided the cosmos in human thought. For centuries, Newton's gravity had held the heavens in its equations, pulling comets, planets, and moons into predictable obedience. Einstein later expanded that vision, curving space-time itself, teaching us that gravity was not force but geometry, a bending of the very stage upon which celestial bodies moved. Hawking, with his explorations of black holes and quantum horizons, had shown how fragile those laws might be at their extremes. And now, into this lineage of certainty and challenge, came Atlas, refusing to fit. For Newton, the puzzle was motion. An object on a hyperbolic path was permissible, but its refusal to brighten, its silence of jets, contradicted the cometary explanations his framework might expect. For Einstein, the concern was subtler. The trajectory should be calculable with exquisite precision, yet deviations hinted at forces beyond curvature alone, nudges that space-time itself did not account for. And for Hawking, the silence of Atlas spoke to the deeper tension between relativity and quantum fields, where the vacuum is alive with possibility, and matter may behave in ways no classical law can fully describe. The fragile fabric of law was not torn, but it was strained. Atlas did not violate Newton or Einstein outright, but it brushed their boundaries, reminding us that every law is provisional, every framework a map rather than the territory. It was as though the object hovered precisely at the limits of comprehension, a messenger sent not to destroy our physics, but to remind us that physics is never complete. This was not new. Throughout history, anomalies have been the seeds of revolution. The orbit of Mercury once defied Newton until Einstein resolved it with relativity. The spectrum of the Sun once baffled astronomers until quantum mechanics revealed the language of atoms. Might Atlas, then, be another such anomaly, a quiet herald of theories yet unborn? Some physicists whispered of modified Newtonian dynamics, of extensions to general relativity, of interactions between dark energy and small bodies. Others imagined subtler forces, unmeasured fields, couplings, hidden deep within the equations of quantum gravity. None could prove their case, but all agreed on one point. Atlas revealed how fragile our laws can feel when pressed by the unexpected. Even culturally, the resonance was clear. Humanity has always clung to law as reassurance that the universe is orderly, that its rules can be known. When an object like Atlas slips through, resisting those rules, it unsettles not only our science but our philosophy. If the laws can falter, what else that we take for granted might be provisional? Time? Space? The very continuity of reality? And so, the image of Atlas became symbolic. It was no longer only a dim interstellar traveler, but a reminder of the fragility of certainty itself. Newton's apple, Einstein's space-time, Hawking's event horizons all were chapters, not conclusions. Atlas brushed past Mars to whisper this truth once again. The laws we hold sacred are scaffolding, not stone. They hold us for now, but the cosmos will always find ways to bend them, to remind us that discovery is never finished. In this sense, the strangeness of Atlas was not merely astronomical, it was existential. It forced us to confront the fragility of knowledge, the humility of our position. Every equation is a lighthouse, but the sea of the unknown stretches infinitely beyond. There was another whisper that haunted the analysis of Atlas, one far more unsettling than dark matter or quantum drift. It was the spectre of instability in reality itself, the idea that the vacuum of space may not be permanent, but precarious. Physicists call it the false vacuum hypothesis, the possibility that what we know as the fabric of existence is not the universe's true ground state, but a fragile plateau, vulnerable to collapse into something deeper, stranger, and final. In this picture, the vacuum is like a ball resting on a hilltop, stable only by accident. At any moment, through quantum tunneling or cosmic disruption, it could roll down into a lower valley, a true vacuum rewriting the laws of physics in an instant. Every particle, every star, every atom of our bodies would dissolve, transformed by a wave of annihilation expanding at the speed of light. Why then did Atlas call this spectre to mind? It was not that the object itself threatened collapse, but that its silence, its irregularities, its defiance of explanation pressed on the unease that our cosmos is less secure than it seems. When instruments failed at the moment of closest approach, when spectral fingerprints yielded emptiness, when its orbit carried faint deviations without reason, some wondered, could this be the signature of the vacuum itself shuddering? Could the silence be not artifact, not censorship, but reality itself shifting beneath our laws? Speculation grew darker still. A few theorists, half in jest and half in dread, mused that perhaps Atlas was a fragment of such a transition matter born not of ordinary stellar nurseries, but of a domain where vacuum had already collapsed. If so, then it would not behave like our matter, nor reflect like our rock, nor brighten like our comets. It would be, in essence, an emissary of another phase of reality. Such ideas remained on the fringe, whispered in papers more philosophical than empirical, yet their presence revealed the depth of unease Atlas inspired. For if the universe truly is balanced on a false vacuum, then the silence of an interstellar visitor could be seen not as accident, but as omen, a reminder that existence itself is contingent, temporary, awaiting the moment when the quantum dice finally fall. The silence at Mars, then, became more than an observational failure. To those haunted by this possibility, it was almost symbolic, a blank moment in the record, as though the universe itself had demonstrated how easily continuity can vanish. If the vacuum is fragile, then our laws are fragile. If the vacuum can collapse, then so can our stories, erased in an instant like a data stream cut to black. It is perhaps no surprise that such reflections were kept quiet. The public imagination is rarely ready for a cosmos that can end without warning. But among physicists, Atlas revived the conversation. Was its silence natural, or was it a faint echo of a deeper silence lurking in the foundations of being? If the vacuum itself trembles, then perhaps every interstellar visitor is a reminder not just of other worlds, but of the instability of reality itself. And if that is true, then Atlas did not come only from the stars. It came from the abyss beneath the stars, carrying in its silence the most terrifying question of all. Is existence itself safe? When speculation turns toward the unsteady foundations of reality, it is only a short step into the vastest speculation of all the multiverse. For if Atlas seemed to carry properties not fully at home in our physics, then perhaps it was not fully of our universe. Perhaps it was a shard of elsewhere, born in domains whose laws do not mirror our own. The multiverse is no single idea, but a constellation of theories. Inflationary cosmology suggests that the Big Bang may not have been unique, that as space expanded, bubbles of reality sprouted endlessly, each with its own constants, its own chemistry, its own physics. String theory imagines landscapes of possible universes, each a valley in an infinite field of energy. Even quantum mechanics, with its branching possibilities, whispers of parallel histories unfurling alongside ours. If such realms exist, then debris might cross the boundaries. Cosmic inflation could fling material from one bubble into another. Quantum domains could bleed across imperceptible seams. A body like Atlas might not be an ordinary comet at all, but an immigrant from a neighboring universe, carrying within it signatures of laws alien to ours. Its refusal to brighten, its erratic dimness, its strange trajectory, all could be the marks of matter that does not behave according to our rules, because it was never forged beneath our stars. Some physicists caution against such ideas, for they stretch beyond testable science. Yet the silence of Atlas seemed to invite them. Its absence of clear cometary activity, its faint but steady anomalies, its vanishing from instruments, these were the behaviors of something that did not belong. And if it did not belong, then where did it come from? Speculative papers imagine scenarios: a fragment torn from a collapsing vacuum bubble, flung across domains, a probe from another universe, drifting deliberately through seams in space-time. Even the notion of Atlas as a messenger, carrying encoded geometry, a pattern not of natural rock, but of information woven into matter itself, meant to cross the gulfs between universes. Of course, none of this can be proven. No telescope can confirm other universes in a light curve. Yet, speculation often precedes discovery. Once, the idea of other galaxies was fantasy. Once, the idea of invisible matter was absurd. Perhaps, too, the idea of inter-universal debris will one day pass from speculation into science. For now, Atlas remains only a whisper of this possibility. But in its silence, in its refusal to yield to the categories of asteroid or comet, it plays the role of invitation. The multiverse may never be proven, but it lives in the gaps of observation, the gaps of law, the gaps where anomalies like Atlas linger. And if the multiverse is real, then Atlas may not be a lone traveler at all. It may be the first stone thrown across the river of worlds, a hint that the boundaries between universes are thinner than we dare imagine. Its silence, then, is not emptiness. It is the muffled voice of another cosmos, brushing ours for a moment before vanishing again into the unknowable. There is another lens through which Atlas may be seen, one that steps beyond physics into the ancient question of intelligence itself. For if its silence was deliberate, if its trajectory bore the faintest trace of intention, then perhaps Atlas was not merely stone or ice, or even exotic matter. Perhaps it was a vessel of thought, a fragment of cosmic intelligence drifting between stars, carrying with it a message too subtle or too alien for us to decipher. The idea unsettles, yet it lingers. Intelligence does not always announce itself in the ways we expect. Humanity, when it first sent probes into space, crafted plaques and golden records, messages etched in metal, designed to be discovered. But what if another civilization had chosen silence instead? What if the truest message was not in words or signals, but in the geometry of motion, in the quiet arrival of an object that brushes a neighboring planet and disappears? Atlas could be interpreted as artifact, yes, but not artifact in the crude sense of machinery. Rather, it could be seen as a form of thought crystallized in matter, a fragment designed to resist interpretation, to provoke reflection, to pass silently, just close enough to be noticed, yet opaque enough to evade classification. Its silence, then, would not be failure, but philosophy, a reminder that intelligence does not exist to soothe our curiosity, but to stretch it. Some scientists entertained a different version of this idea. Perhaps cosmic intelligence is not localized at all, not bound to ships or machines or civilizations, but woven into the very structure of the universe. Perhaps interstellar objects like Atlas are expressions of that intelligence, emergent patterns in the flow of galaxies, self-organizing whispers of a cosmos that thinks. In this view, Atlas is not a messenger from intelligence, but intelligence itself, embodied in the chance alignments of matter and trajectory that unsettle us precisely because they feel intentional. To speak of intelligence in the cosmos is dangerous, for it tempts anthropomorphism. Yet the strangeness of Atlas makes the thought hard to dismiss. Its path near Mars could be read as accident, but also as symbol. Its disappearance from instruments could be technical, but also as design. Its refusal to shine, to erupt, to explain itself, was this not exactly what an intelligence might do if its goal was to provoke not answers, but questions? For what is intelligence, if not the capacity to seed questions in another mind? To make others wonder, doubt, imagine? By that measure, Atlas achieved more than any open broadcast could have. It unsettled physics, strained observation, and left behind a silence heavy with meaning. And so, some dared to whisper, perhaps we have already encountered cosmic intelligence, not in the crash of signals or the glimmer of cities on distant planets, but in the quiet brush of a single object past Mars, a silence too eloquent to be mere chance. If so, then Atlas was not only a visitor, it was a mirror. It reflected humanity's hunger to know and the limits of what can be known. And in that reflection, it reminded us of something profound, that intelligence is not always in the answers, but in the silence that compels us to keep asking. What unsettled scientists most about Atlas was not only its silence, but the hunger it ignited. For at its core, the mystery was less about an object and more about humanity's ancient compulsion to explain. The unknown is intolerable to the human mind. It gnaws, it provokes, it drives entire civilizations to watch the skies, to write equations, to invent stories, and yet Atlas defied that need. It came and went without surrendering meaning, and in doing so, exposed the restless engine of our own philosophy. The Greeks once called philosophy the love of wisdom, but it has always also been the fear of ignorance. From Plato's cave to Kant's categories, from Descartes' certainty to Nietzsche's abyss, every attempt to frame reality arises from the unease of not knowing. Astronomy, for all its numbers and telescopes, is no different. It is philosophy written in photons, an attempt to bring meaning to the endless dark. Atlas, however, reminded us that not all mysteries yield. Its refusal to brighten mocked our expectations. Its trajectory teased the improbable. Its disappearance at Mars silenced our instruments, as though to say, knowledge is not guaranteed. And in that silence lay a profound philosophical tension between the universe as knowable, rational, law-governed, and the universe as unknowable, mysterious, resistant. Some thinkers embraced this resistance. They recalled Pascal, who spoke of the eternal silence of infinite space as terrifying yet sublime. They recalled Heidegger, who saw in mystery the essence of being itself. Atlas became, in this light, not a scientific failure but a philosophical triumph, a reminder that the cosmos exceeds our categories, that reality cannot be caged in certainty. For others, the silence was intolerable. They demanded answers, framed theories, forced simulations. They saw in Atlas not mystery but threat, a destabilization of science's authority. For if an interstellar object can defy explanation, what else in the cosmos might resist? To admit ignorance was to admit fragility, to reveal that even in an age of space telescopes and supercomputers, humanity is still in its infancy. The philosophy of Atlas, then, was double-edged. It reminded us both of the nobility of our pursuit and the humility of our limits. It revealed that knowledge is not a fortress but a lantern flickering against vastness. And it asked the oldest question of all: why must we know? What drives us to pierce every silence, to turn every absence into theory? Perhaps that was the object's true lesson. Perhaps the silence of Atlas was not a puzzle to solve, but a mirror to hold. In its dim passage near Mars, in its refusal to conform, it revealed less about itself and more about us, our insatiable thirst, our terror of the unknown, our yearning to frame even the unframeable. The philosophy of the unknown is not comfort. It is not closure. It is the slow acceptance that some mysteries do not diminish us by resisting, but enlarge us by enduring. Atlas came and went in silence, and in that silence it gave humanity not answers, but a deeper question. Can we learn to live with wonder unfulfilled? Silence can be more revealing than noise. In astronomy, the absence of signal is itself a kind of data, a void that outlines the shape of what might have been. When 3I Atlas slipped into obscurity, its very failure to behave like an ordinary comet or asteroid became part of its story. It was not only what we saw that mattered, but what we did not. Astronomers call this the science of non-detection, to look for something, not find it, and yet learn from that absence. When telescopes searched for cometary outgassing and found none, the silence spoke. Atlas was not rich in the usual ices. When spectrographs sought the fingerprints of water or carbon monoxide and returned empty, the silence again was telling. Its surface chemistry was alien or sealed or deliberately hidden. When instruments failed in synchrony, the absence itself became the anomaly, louder than any positive signal could have been. This paradox, absence as presence, gave Atlas its most haunting quality. Every attempt to study it ended not with confirmation but with negation. It was not a comet, not an asteroid, not visible at the moment of closest approach, not traceable in familiar spectra. Each "not" was a shadow, and together the shadows formed a shape more provocative than light. Philosophers of science have long wrestled with this. Karl Popper argued that falsifiability, what something is not, is the heart of knowledge. In that sense, Atlas was generous. It carved away possibilities with every silence. It was not ordinary, it was not obedient, it was not fully explainable by the tools we had. And yet, there was a deeper unease. Absence can be read in two ways, as natural silence or as deliberate concealment. Was Atlas simply inert, too dim and too distant for our eyes to hold? Or was the silence a mask, a geometry of invisibility chosen by the object itself or by those who control what is revealed? This ambiguity made every gap in data double-edged. What looked like noise might be signal, what looked like error might be design. The astronomy of absence forces us to confront an uncomfortable truth. The universe is not obligated to reveal itself. We may gaze with the finest mirrors, send probes across gulfs of space, bend the spectrum into rainbows of analysis, and still the cosmos may turn away, refusing to answer. Atlas embodied that refusal. It reminded us that the universe owes us nothing. And yet, in that refusal, wonder grows. For absence is not failure, but invitation. Each silence leaves room for speculation, for imagination, for humility. The gaps in Atlas's record are not empty. They are alive with the very questions that drive us to build better telescopes, to sharpen our theories, to dream of one day following an interstellar visitor, not from afar, but up close, side by side. The astronomy of absence is thus not resignation, but anticipation. Atlas slipped away, leaving more questions than answers, but in that silence it lit a fire. It reminded us that mystery is not the enemy of science, but its fuel. And sometimes, what we do not hear tells us more than what we do. Though Atlas drifted into silence, astronomers knew this would not be the last encounter. Interstellar wanderers are rare, but not singular. ʻOumuamua came in 2017, Borisov in 2019, Atlas in 2024. Already, 3 in less than a decade suggested not miracle, but inevitability. The void between stars is littered with debris, and sooner or later, more will pass our way. The question is not if, but when. Simulations of galactic dynamics estimate that trillions of fragments, rocks, comets, icy shards roam the interstellar medium, ejected by young planetary systems, hurled outward by gravitational chaos. Most never approach our Sunday, but the solar system drifts through the galaxy like a ship through dust, and chance dictates that visitors will cross our path. With each decade of better instruments, the likelihood of detection rises. Astronomers have already predicted that the Vera Rubin Observatory will detect dozens, perhaps hundreds, of such interstellar objects once its survey begins. Each one will be charted, tracked, studied with unprecedented fidelity. The age of rarity will end, the age of encounter will begin. And so, the question becomes, what will the next one bring? Another pristine comet, shedding gases from alien chemistry, another shard of rock, accelerating inexplicably as if propelled, or something stranger still, an object that, like Atlas, resists categorization, refuses to reveal itself, vanishes at the moment of closest scrutiny. The thought is both exhilarating and sobering. Exhilarating because each visitor carries within it the story of another star, another planetary system, another chapter of galactic history. Sobering because each also seems to deepen the mystery rather than resolve it. If 3 interstellar guests have already unsettled us, what will 10 do? What will 100? Will the anomalies begin to converge into a pattern, or will each bring new dissonance, leaving us forever uncertain? Some dream of missions, not just telescopes. Concepts already exist for spacecraft capable of rapid interception, launched at a moment's notice to chase a visitor, to rendezvous, to look upon it, not as a distant speck, but as a world at close range. If humanity builds such a fleet, then the next Atlas will not slip silently past Mars or Earth. It will be met, examined, confronted. Until then, the silence lingers. Atlas has gone, its trail fading into interstellar dark. But others will follow, each a reminder that the universe is not closed, that the gulf between stars is not empty. They will come without warning, without invitation, as emissaries of the unknown. A future encounter awaits, inevitable, unavoidable, and perhaps decisive. The cosmos is not finished with us. Its messengers are already on their way, and in them, we may one day find the answers Atlas withheld, or deeper silences still. When the story of 3I Atlas is finally told in full, it will not be remembered for what it revealed, but for what it withheld. A faint interstellar visitor, it entered our awareness like a shadow on water present, undeniable yet impossible to hold. It carried the promise of knowledge, then vanished into silence, leaving behind only questions. And in that void, humanity was forced to confront something larger than data, larger than science itself, the eternal question of what mysteries mean. The silence surrounding Atlas was layered. It was the silence of the object itself, refusing to brighten, refusing to whisper chemistry into our spectrographs. It was the silence of instruments, failing or faltering at the moment of greatest need. It was the silence of institutions, withholding words that might have steadied us. And above all, it was the silence of the cosmos, a reminder that the universe does not exist to explain itself to us, that its riddles are not always written in language we can translate. What does this mean for us? Perhaps nothing more than humility. We are young, a species just beginning to stretch its eyes beyond its own cradle. We expect answers, yet the universe offers questions. We crave certainty, yet the stars respond with riddles. Atlas came not to enlighten us, but to remind us that our journey into knowledge is endless, that every discovery leads not to closure, but to deeper wonder. And yet, there is comfort in this, for the mystery of Atlas is not failure, it is continuity. It is part of a story far older than us, a story in which the cosmos withholds as much as it reveals, so that curiosity may never die. The silence is not emptiness, but invitation. An invitation to keep watching, to keep building, to keep dreaming. Atlas has gone now, slipping back into the gulf between stars, but its passage lingers, like a faint note struck in the darkness, resonating long after the sound has ceased. We will hear it again, in the next visitor, and the next, and perhaps one day we will understand, or perhaps we will not. Either way, the silence will endure, and in it, so will our wonder. The night sky stretches on, unbroken and eternal. The stars shimmer, as they always have, indifferent to our questions, patient beyond measure. In the quiet aftermath of Atlas's passing, there is no resolution, no final word, only the slow recognition that the universe's greatest gift is not clarity, but mystery. Imagine standing beneath the dark canopy of the heavens, looking upward with nothing but your eyes. The stars are distant, the silence complete. Somewhere out there, Atlas is already gone, receding into distances where no telescope will follow. Its secrets remain intact, sealed in darkness. And yet, in its refusal to yield, it has given us something profound, the reminder that we are participants in a cosmos that will never be fully known. Let the silence soften now. Let it stretch, not as an absence, but as a horizon. For beyond every unanswered question lies another dawn of discovery, another chance to look upward and wonder. The universe is not cruel in its mysteries. It is generous, gifting us the endless task of searching, the endless joy of not yet knowing. Sleep now with that thought. The stars will keep their vigil. The cosmos will continue to weave its riddles across the sky. And though Atlas has slipped away, others will come. We will meet them with sharper eyes, braver questions, and the same awe that has always lived in us. For tonight, the mystery is enough. The silence is enough. The wonder is enough. Sweet dreams.